Good evening, and welcome to Scientific Adventures of Beardman.
Hello? Hello, can you hear me? Oh, we seem to be getting some interference. Oh, well, the video's on interference.
So, sit back and enjoy this as we talk about what happens when two waves get to the same place at the same time. Well, when two waves get to the same place at the same time, we might at first imagine the same thing would happen if two tennis balls got to the same place at the same time. They'd hit and bounce off each other. Well, it turns out that's not how it works with waves. So, when waves get to the same place at the same time, they pass right through each other. Yeah, they just keep going. It's a little bit crazy. It's hard to picture, hard to understand, but we'll show some examples, and hopefully you can see some in class. If you take a string or a slinky, you can send waves at each other and convince yourself that they do indeed just pass through each other. What's really interesting, though, is what happens when they are actually at the same place at the same time. What happens when we get two waves at the same place at the same time is we get interference. Now, what does that mean? Basically, it means that two waves both affect the medium the way they would have on their own, and then you just add those together. Okay, so in other words, if two waves came in like this, two wave pulses came in, well, if they were at this place at the same time, this one would make it go here, this one would make it go here, so together they're each pushing the medium that far above equilibrium. So how far is it going to go above equilibrium? Well, if they're each pushing it that far, it's going to end up going that far above equilibrium. Twice as far. Okay? Now, of course, the waves don't have to be identical. One could be smaller than the other, in which case you add this much to this much, and it goes up that much. Okay? That's a process called constructive interference. Both waves are pushing the material the same way, and so they work together and push it higher or farther from equilibrium. The other option is, of course, completely valid as well. Two waves, how do I get my hand to do that? Two waves come in and they're going opposite directions. And so as they're here, this one's trying to pull the material this way, this one's trying to pull the material that way, and so the atom doesn't move. It gets pulled one way and the other way and doesn't move. We call that destructive interference. So destructive interference is when the two waves oppose each other and cancel out, or partially cancel out. If you had a big wave and a small wave come in, the big wave wants to pull it that much up, this one wants to pull it this much down, well, it kind of subtracts off and it ends up being about that much up. That would be partial destructive interference. Okay, so we either get destructive interference or constructive interference, making the amplitude bigger. Okay, now remember, once this happens, the two add together, give us an extra big wave, and then they carry on their own direction, just as they were going to begin with. Okay, you can see that in the simulation here. As the two waves come together, they add up here to the maximum amplitude, and then they carried right on. They just moved on. They passed through each other. You can see it a little bit easier to tell that they pass through each other when we see the destructive interference simulation. The one on the bottom ends up being on the bottom, and so we see it carry through. But you see, as they get to the same place, the wave cancels out, the two wave pulses cancel out, and we get destructive interference. The mathematical principle that we kind of hit on, that when you take the height of one and the height of the other and add them together, or the height of one and the depth of the other and subtract them, that idea is called the principle of superposition. Okay, so you'll see that when we take the general concept of interference and put mathematical numbers to it, we call it the principle of superposition. Now, this can be a very interesting phenomenon, because if you have two waves coming from somewhere, they will interfere. And so, for example, if you have two speakers, those send out sound waves and they will cause interference. And so at some places, depending on the frequency, that will cause destructive interference. Other places it will cause constructive interference. So the person sitting next to you at a concert, if they had two speakers, okay, in the front, and they didn't pay attention to all these issues called sound engineering, you may get a very different concert than the person sitting next to you or a few seats down the row. So it's something that's very important for a band or anyone concerned with sound, creating it for movies or speaker systems in cars, to be aware of interference, because if it interfered and destructively interfered, you wouldn't hear much. It'd be very hard. And the person next to you would get constructive interference, and it'd be really loud, and they'd keep turning the radio down, you'd keep turning it up, and it would cause a lot of family strife. So we wouldn't want that. So it's a good thing people pay attention to interference. The other great place that people have used interference very wisely is in noise-canceling headphones. So you might do a little bit of research and see if you can figure out how they use the property of interference to create noise-canceling headphones. All right, enjoy that. It's actually a very interesting study. So we'll see you next time on the Scientific Adventures of Beardman.